Right. In our last class, in our last class, what we learn is we learn the range of optimality. Okay, we learn range of optimality. So what is range of optimality? Let me recall back. We focus on this number 3 and 2 here, the coefficient of A and B. We denote this A with the 3 with CA and the 2 with CB, and then we find the range for the CA and also CB. What was the range? That would be, this is what we found. CA is in between 2 and 6, and CB is in between 1 and 3. Later, interpret. Let me teach you how to do these things first. So this number here, the 3 here, okay, I can write the 3. I can replace the 3 up to 6, and I can reduce the 3 up to 2. This number 2 here, I can increase until 3, decrease until 1. That is the range. That's the thing. So what does this number represent? Hold on, there's a story behind it. Now, the same thing, something similar, we are going to find another range for this number. Okay, for this number, I'm going to write right hand side 1. This one going to be right hand side 2. And this one going to be right hand side 3. Okay, RHS is right hand side. Okay, that is RHS. The name for it is range of feasibility. So we're going to do range of feasibility today, right? Anybody copy first. Alright, so let us go back to the example 1 again. Alright, so first thing is range of feasibility we're going to find for binding constraint first. Okay, for example 1, we're going to go for binding constraint. We will focus on binding constraint. For example 1, still remember what is the binding constraint. If you look at here, example 1. The binding constraint is C1 and C2. So your binding constraint will be C1 and C2. We focus on that first. Now, C1 is here, C2 is here. So what we are going to find is, we are going to find what is our aim is, this is right hand side 1, right hand side 1. So my aim is to find an upper bound. This is called upper bound. This number is known upper bound. This number is known lower bound. So I am going to find what is the upper bound and lower bound. That is my idea. Exactly the same thing. Like what is my upper bound here? 6. What is my lower bound here? 2. Techniques is different. Range of optimality is easy. Range of feasibility little bit difficult, complicated. Alright. So first of all, what will happen? What will happen if I increase or decrease this 10 here? Okay, I'm going to find upper bound. Upper bound. Upper bound for C1, C1. So what will happen if I increase this number or decrease this number? The line will go up and down. That's the idea. So when I say increase and decrease, you have to think the line, you have to imagine the line, how far I can push the line, how far I can bring down the line. This was the diagram. Is there any diagram? No diagram. Let me put it this way. This is the diagram. Where is C1? C1 is this is C1 here. Get it? Okay. Now we are focusing on binding constraint. What is binding constraint? C1 and C2. Why we call it binding constraint? Sebab optimal solution berlaku di antara C1 and C2. C3 tak ada kena. C3 is non-binding constraint. Now my question is, garis ni saya nak naikkan ke atas sebab sekarang nilai dia adalah 10. Bila nilai dia 10 dekat sini gitu. Bila saya naikkan dia, garis ni akan naikkan. If I increase this value, the line going to go up. So how far I can bring it up? How far I can increase the 10? That's the idea. Now, the condition is like this. Let me write the condition here. The condition is, okay, put it here. Bila saya naikkan, if I increase the line, intersection must happen between C1 and C2. Why? Because now the optimal solution is in the intersection of optimal solution is in between C1 and C2, isn't it? So when I increase, I must make sure that this is the condition. If I increase this line above, there must be always an intersection. Kalau saya naikkan sini, ada intersection tak? Naikkan sini, ada intersection tak? Naikkan sini boleh, sini boleh, sini boleh kan? Tak boleh. So according to the first condition, tak boleh. So I can raise the line until here. Here cannot. Okay, so first condition is intersection always must happen in between C1 and C2. Why C1 and C2? Sebab optimal solution between C1 and C2. Kalau optimal solution between C1 and C3, then intersection must happen always between C1 and C3. Okay, understand? Huh? Alright. Second condition is, look at the original graph here. This optimal solution, look at the non-binding constraints sekarang. Ini binding constant. C1, C2 is binding constant. Non-binding constant is C3, isn't it? So the second condition goes for non-binding. Optimal solution ni bawah C3 kan? So when you move the line, you have to make sure persilangan tu, intersection tu always below C3. So second condition is optimal solution below C3. Why? Because the original condition like this. Okay. So now I'm asking again. I can increase this line. Can I increase like this? Can I increase like this? Can. But can I increase like this? Because now the intersection is above C3. Dia kena sentiasa below C3. Now I'm going to show you geometrically. Okay. So two condition. This is a good two condition. Let us go to this one. Original value is 10 here. You can see 10. The purple color line is the C1. Okay, can you guys see? I'm going to increase now. Can you see the line moving? Okay, original value is here. Okay, this is the optimal solution. Optimal solution dekat sini sekarang. Okay, saya nak naikkan garis ni. What is the condition? Persilangan intersection must happen. And intersection must happen below C3. So, tell me, where should I stop? Okay, tell me. Boleh naik ke? Sampai sini sahaja. But, repeat. Original dekat sini. Saya kena naikkan garis tu. Condition is intersection must happen in between the purple color and the brown color. This one. And then intersection is always below the green color. I'm increasing. I'm increasing until here. If I go above, the intersection is above green line. Can you see? So I'm going to stop here. That is batasan saya. That is the limit for me. That is where I should stop. Okay? Now, after you identify the thing, can you see this is the point, isn't it? This is the point. Can you see this point? This point? That point we have to find. We have to find that point. What is that point actually? That point is actually here. This one. Titik. Okay, that is titik. This point is intersection between C3 and C2. Can you see? If you want to find intersection point, you have to do simultaneous equation now. C3 and C2. So far so good, can you understand? We increase. When you increase, you identify where to stop. That stopping point, find that stopping point. Find that stopping point. Let us find that stopping point. Okay? Find that stopping point. So my upper bound will start. My stopping point will be intersection between C2. C2, what is my C2? C2 is 3A plus B equal to 4, and C3 is A plus 2B equal to 16. Now, why I write C2, C3? Because the point is intersection between C2 and C3. I'm going to do a simple simultaneous equation, the one you did in Form 5. With substitution, you can do elimination if you want. 3A. Substitute inside B. Copy first one. So the point, just now the point I told you, the point is actually 6.4 and 4.8. We found out the point already. Okay, copy first, this one, copy first. Okay guys, so once you find this point, how to find, we have to find the upper bound yet. How to find the upper bound? Replace this point inside C1. What is C1? A plus B. Replace inside here. My A is 6.4 plus my B is 4.8. My upper bound would be 11.2. This is my upper bound. This is my upper bound. Copy this one. So what we did here, okay, what we did here, first what we did, we find the upper limit point. We find the upper limit point. Where is the upper limit point? This one. Kita cari satu titik. Okay, lepas tu apa kita buat? Nombor 2, nombor 1 Ini nombor 2. Apa kita buat? Substitute in C1. Okay, yang ini. Cari titik, substitute inside C1. Kenapa C1? Sebab kita nak cari upper bound for C1. Kalau C2, you substitute dalam C2. That's the idea. Okay. Okay, first. At first, might be difficult. Later on, once you do a lot of exercise, you will understand. But don't worry, this is manually. I'm teaching you manually. Lepas ni saya akan ajar you dalam satu software. Saya akan buat satu recording lah, software. Dalam software tu, you tekan yang ini, you masukkan nilai ini, yang ini, masukkan ini, yang lain semua dia akan cari untuk you. Okay? Why I'm teaching you this is your assignment. So in the assignment, you have to show me the working, and also you have to show me the software. Kalau you punya working tu tak sama dengan software, you jangan hantar saya. Sebab jawapan salah. You punya working and the software punya number kena sama. So basically you will get 100% betul bila you hantar saya. Kecuali you punya, you tiru orang lain ke, ataupun you punya calculation agak salah, tiba-tiba answer betul, itu saya akan check lah benda tu. Just want to get to know the idea what's going on there. Okay, this is done. After upper bound, what we have to find? Lower bound. Let us go for lower bound. Lower bound of C1. Again, lower bound of C1. Now, before I show you the thing, C1 is here. Same condition, intersection must happen, and the intersection always below C3. Boleh saya turunkan garis ke sini? Bawah ni? Boleh, intersection dekat sini. Kalau you turunkan dekat sini, kalau if you decrease, if you lower down the line, the intersection is always below C3, isn't it? So yang ini tak perlu risau lah. It's always going to happen. Sentiasa akan berlaku. Yang you perlu risau adalah yang ini. Intersection happen ke tak? So you turunkan dekat sini boleh. Kalau you turunkan dekat sini still boleh. Kalau you turunkan dekat sini boleh ke? Sebab garis dekat sini, yang ini sampai sini je, tak berintersect, tak ada persilangan. So now I'm going to show you the graph here. Okay. Sekarang saya turunkan dia. Saya turunkan sampai sini boleh, sampai sini boleh, sampai sini boleh, still ada intersection Sampai sini boleh, sampai sini boleh, ini boleh ke? Tak sentuh dah, tak boleh. So you kena naikkan balik. Mana dia punya titik? Dia punya titik adalah dekat sampai ini dah dia punya limit. Sampai sini saja dia boleh. Ini dia punya titik, boleh faham? Dia punya titik, yang ini. Ini dia punya titik. Yang ini. Itulah dia punya titik. So this is your lower limit point. Tadi upper limit point apa? Yang ni, upper limit point. So ini adalah lower limit point. Okay, saya nak tanya, what is this point actually? Semua selalu lupa Sekejap. Katakan ada X, Y, ada satu garis macam ni. Nama ni apa? Namanya adalah X-intercept. Masih ingat tak? X-intercept. Ini adalah Y-intercept. Macam mana nak cari Y-intercept? You ganti X sama dengan kosong. X-intercept, ini bukan saya dah ada kan sebelum ni. Okay. Jadi kalau ini X, ini Y, kita punya apa? A dengan B. Kalau A dengan B, ini A, ini B. Katakan garis macam ni. Ini adalah kita punya A intercept. Ini adalah B intercept. Kalau saya nak cari A intercept, saya akan gantikan B sama dengan kosong. Yang ini A sama dengan kosong. Same thing, I'm going to do that. Now, this is my A intercept. A intercept garis apa ni? C2 kan? C2 kan? Garis C2. C2 apa? C2 3A plus B. My C2 is 3A plus B 24. Okay. So if I want to find my A intercept, saya gantikan B sama dengan kosong. Why B sama dengan kosong? Saya punya A intercept. Point itu adalah A intercept. So dia punya point adalah 8, kosong. Salin ini. Ini adalah point dia. Lepas dapat point dia, dapat salin itu. Once you get the point, what you have to do, replace inside L, replace inside C1. So So you find the lower bound. This is also same, lower bound. Find the lower limit point, that is number 1. Number 2 is substitute in C1. So the answer is right hand side 1. Kita dah cari upper limit, lower limit. Upper limit was 11.2, lower limit was 8. This is the answer. Alright, this is for C1. Okay, we just found for C1. We have to go for C2 now. Okay, so upper bound for C2. Idea is the same thing. Upper bound for C2. For you to find upper bound for C2, same idea. The condition is the same. Sekarang C2 dekat sini. C2 dekat mana sini? C2 dekat sini. How far I can bring this up? Okay, how far can I bring here? Boleh. Persilangan di sini. Masih bawah C3, boleh. Yang ini boleh, yang ini boleh, yang ini boleh ke? Persilangan tak berlaku. No. Intersection. If I move, if I show you here. Okay, C1 don't disturb. Go for C2. C2, dia punya original value is 24. C2 is the brown color line. Now the original intersection is here below C3. Kalau saya naikkan dia, dia akan gerak ke atas, gerak sebelah ke kanan. Saya gerak, still happen. The intersection happen below C3. Still going. Sini boleh ke? Tak boleh. Sampai sini sahaja. Boleh nampak? Boleh? Can you guys understand? Now I can bring this line up to here. This point. What is this point actually? This point is actually A intercept of C1. Can you guys see? A intercept of C1. So go back here, upper bound, write C1. What was C1? A plus B equal to 10. A plus B equal to 10. And if A intercept, make B equal to 0. inside C1. Sorry, C2. C2 is what? 3a plus 3a plus. When you substitute, don't take the value, just take the AB only. Upper bound is 30. Same thing goes here, same condition right here. Upper limit substitute in C2. Why C2? Because we are finding upper limit for C2. Find the point, substitute, that's it. Now, I give you some time. Can you find me lower limit for C2? Salah cover, cuba. Salah cover. Cuba. Find me the lower limit for C2. How far you can bring down? So if you bring down this line, here still can. If you bring down, garis ni ke sini masih boleh. Persilangan dekat sini Sini boleh, sini boleh ke? Intersection is here but above C3, so cannot. You have to stop here. Did you guys did this? Dapat? If I want to show, I bring down. Original was 24, so this is somewhere here. So I bring down. Look at the brown color and the purple color intersection. It will go all the way up here. All the way can until here. If you move above, the intersection goes above C3. Tak boleh. So dia kena turun sampai sini sahaja. Sampai sini saja. Boleh faham? Now, what is this point? What is this point? This point is intersection between C1 and C3. Let us find the point. Lower bound, the point is 4, 3 and then substitute inside C2. So we have found lower bound and upper bound. So the answer is RH2 is 18 here and 30 here. That's the answer for range of feasibility for RH2. So if a line is like this, we increase the number, the line will go up. Okay. If I decrease the number, will line go down. Kalau line macam ni, dia akan pergi sebelah sini, atas ke bawah macam ni. Boleh faham? Kalau line dia horizontal, mendatar. Kalau increase, dia akan naik ke atas, decrease, turun bawah. Okay? Kalau the line is vertical, like this. Kalau increase, it goes kanan, decrease, it goes kiri. Can you understand? That's the idea. Now, so far what we did is, we did for binding constraint. We find the range of feasibility for binding constraint. C1 and C2 done. Now we are moving for non-binding constraint. Yang ini senang saja. Yang ini senang saja. Contohnya lah, contoh. Katakan ini adalah you punya optimal solution. Optimal solution. Sekarang you punya non-binding constraint, katakan di atas macam ni. Okay, katakan di atas. Bila saya gerakkan garis tu ke atas, dia ada sentuh optimal solution tak? Tak ada kan? So RH dekat sini kita punya non-binding constraint lah RH3. Ini adalah kalau saya naik atas tak ada batasan, boleh pergi sampai atas mana-mana. Kita letak infinity, nombor yang paling besar, infinity. Berapa banyak kita nak naik pun boleh, no problem. Tetapi turun, bila turun dia ada sentuh optimal solution kan? Bila turun, ambil optimal solution ni, ganti dalam ni. Contoh, katakan equation ini A plus 5B at some number, you don't worry about the number. Okay, katakan optimal solution dekat sini 1, 1, contoh 1, 1. Gantikan 1, 1 dalam ni, dapat apa? Quick one, 1 times 1 plus 5 dapat 6, itu saja. Contoh, nanti kita akan buat kita punya dia. Okay, okay, ini pen lah, kejap. Ini alternatif 1, ini A1. Sekarang saya nak lukis gambar yang sama. Katakan sekarang ini sama, ini adalah 1, 1. Optimal solution katakan 1, 1. Tapi dia punya line sekarang dekat bawah. Non-binding constraint dekat bawah. Dekat bawah ni, kalau upper bound saya naikkan, dia kena optimal solution tak? Kena kan? Ambil optimal solution ni, ganti dalam ni, dapat apa? 6. Kalau saya turunkan dia, ada kena tak? Tak. Berapa banyak saya nak turunkan pun boleh kan? Letak negative infinity. Kalau kecil, jadi negatif. Kalau besar, positive infinity, tapi positif kita letak biasanya. Boleh faham idea ni? Okey, ini nak copy ni, copy first yang ni. twice ni non-binding constraint. Non okay. Let us do our thing now. So we have saya tulis ni binding constant adalah C1 and C2. Okay, now I'm going to write again non-binding constraint. This is example 1, a non-binding constraint. Non-binding constraint is C3. C3. Upper bound for C3 now. Let us see upper bound for C3. From the graph here, mana graph tadi? Upper bound for C3. Ini. Kalau saya naikkan C3, ini C3 ya. If I increase the number, it goes up. Any disturbance, I can bring up as much as I can. So just simply put here infinity. Lower bound for C3. Okay. Lower bound for C3. If I bring down, dia ada sentuh optimal solution kan? So ambil optimal solution ni 7,3. Replace dalam C3. C3 apa dia? A plus 2B. A plus 2B. That would give you 13. So the answer is RH3. Upper bound is infinity, lower bound is 13. That's it. This now. Dah, sorry. Do you guys need rest? You want me to give rest or shall I continue? Continue. Okay. One more, last one. We do. What we did here, example 1. We are going for exercise 1. Coba sama juga. Yang ini ya. Exercise 1. Okay. This is the diagram of exercise 1. C1, C2, what is the binding constraint? C2 and C3 ya. Sebab optimal solution berlaku di antara C2 and C3. So right here, binding constraint is C2 and C3. Okay. So we focus on C2 and C3 first. C2 first, upper bound for C2. Okay. So if I want to increase the line, this is C2. If I want to increase the line, I must go bring it up. Can you see until where? Okay, what is the rule here before that? What is the rule? Intersection must happen. Am I going too fast? Copy first. Copy first. What is the rule here? Intersection between the binding constraint, C2 and C3. So when you move the line, you must make sure intersection always happen between C2 and C3. Okay, now number 2, look at non-binding constraint. Ini binding constraint. Non-binding constraint dekat mana? C1 kan? Optimal solution ni sebelah left ke kanan? Kalau kita nampak macam ni ya, dia sebelah kiri. Untuk saya, untuk you pun sebelah kiri juga kan? So intersect the point, I just put here left of C1. So intersection must always happen on your left. Jangan tengok macam ni je. Tapi apa pusingkan you punya badan tengok dekat sini. Tengok macam ni. So left of C1. So condition changes according to the diagram here. But the idea is same. Intersection and where is it? Now kita nak naikkan dia. Okay, this is C2. You want to bring this up. Okay, when I bring this up, dekat sini boleh sebab intersection dekat sini, and it is always left hand side. Boleh. Yang ini pun boleh. Yang ini boleh ke? Tak boleh. So if I want to show you diagram, So original is 6, yeah. So I increase, this is 6. Before that, just let me, yeah. So I increase this, you can see the intersection always happen here, and it's always on the left hand side. So condition kedua tu tak boleh risau sebab dia sentiasa sebelah kiri. Increase until here cannot, because there's no intersection. So you bring down until here. What is this point? This point here. This point. Yang ini. Point ini apa sebenarnya? Point ini apa? 9. Dah ada dah dekat sini. Kita dah, bila you lukis hari tu, dah lukis dah dekat sini 9. So point tu adalah 9 titik ni ya. So for upper bound, we got the titik already, which is 0 and 9. 0, you don't need to compute. Tadi masa you lukis tu, hari tu dah lukis dah tadi. Yang ni, ingat tak yang ni? Yang ini. Point ni lah, ni point ni. Kalau you buat scale, yang ini adalah 9 sebenarnya. Okay. So ambil yang ini 09, ganti dalam substitute in C2. C2 is 2W only. Ambil yang ini saja, C2. That is upper bound for C2. For lower bound, same idea, get the point, substitute. The same idea. So lower bound we have to decrease down. If I decrease down, garis ni saya turunkan dia bawah sekarang. Sampai mana saya boleh turunkan dia ke bawah? Sini boleh intersection happen here, boleh ya? Sini boleh intersection happen here. Can I make it here? Intersection is here, but then it's on the right hand side. Tak boleh, so it's sentiasa left. So if I show you here, I bring down. Initially, original was here, somewhere here. I bring down until here again, intersection is here. All the way here, I can bring down until here. I cannot lower down because intersection on the right hand side. So I can bring up to here, this point. What is this point here? This point. Point ni Point ini adalah intersection between C3 and C1. Nampak tak? C3 and C1. So C3 and C1. C1 is D equal to 4. C3 is 3D plus 2W equal to 18. Okay, saya nak cari point tu. D dah ada, D sama dengan 4. Gantikan D sama dengan 4 ni dalam ni. You will get 3. So the point is 4, 3. Substitute. Even though you get 4 and 3, but substitution you only replace the W part only. This is the answer. Let me double check with the previous class. Hold on, just want to. Six and 18. Okay, copy this one. Anything you don't understand, please ask me. So upper bound, lower bound for C2 done. We have done for C2 now. We are moving for C3. Upper bound for C3 now. We are going for C3. C3 is here. In garis ni dekat sini. This is C3. I want to bring this above. Okay. So saya boleh gerakkan dia dekat sini boleh, dekat sini boleh. Dekat sini boleh tak? Tak boleh. So saya boleh gerakkan dia sampai sini saja. Yang ini. Point ini apa? Kalau saya tunjuk dalam yang ini, saya tadi berapa 6? Yang ini saya boleh naikkan dia ke atas, ke atas, ke atas, ke atas sampai ke sini. Ini point dia. Point dia saya rasa senang. Yang ini point dia senang. Sebab apa? 4, 6 point dia. Tak perlu cari semua tu. So untuk ni point dia adalah point dah cari. Lepas cari point kena buat apa? Substitute dalam C3. C3 adalah 3D plus 2W. You will get 24. Upper bound done. Lower bound for C3. Lower bound for C3, lower bound. So let us bring down. If I bring down the line, sini masih boleh sebab dia punya intersection dekat sini. Yang ini, kalau saya sini boleh ke? Sebab dia tak sentuh dua-dua ni. Okay. Yang ini original was 18. Saya turun, intersection dekat sini ya. Saya turun. Yang ini tak boleh. Saya kena naikkan sampai sini. Yang ini boleh tak? Okey, dekat sini. Titik ni apa? 6, betul tak? Ni 6, titik ni 6. So 0, 6. Itu y-intercept kan? Y-intercept 6 dekat sini. X-intercept 0. X 0. Titik dah dapat dan 3 dalam C3. Jadi 12, 24. Double checking with the previous class. 12, 24. Okay. We have done for binding constraint. Tinggal adalah non-binding constraint, tapi yang itu adalah senang sahaja. Non-binding constraint. Non-binding constraint dekat sini ada berapa? C1 sahaja. For non-binding constraint, upper bound tadi dah salin ya? Upper bound for C1. Upper bound for C1. C1 dekat sini. Kalau upper bound, I told you, I need to bring it to right hand side. Saya kena naikkan right hand side. Dia ada disturb tak optimal solution? Tak ada kan? Kalau saya bawa sini tak ada apa-apa kan? So saya boleh bawa. What is the answer? Infinity. Yeah. For lower bound for C1, dia ada kekangan. So for lower bound, if I bring this line here, Nombor ni kacau kan? So kita stop dekat situ saja. 26. Ambil 26 tu ganti dalam C1. C1 kita apa? D sahaja. C1 kita adalah D sahaja. Dekat sini D apa? 2 sahaja. Itu sahaja. 2 infinity. Dan checking the answer with the previous class. Yeah, 2 and infinity. I hope with these two exercises you guys have some idea how to find your range of feasibility. Benda ni penting untuk you buat assignment. Okay. So we have done 2 exercises. The rest I will do a recording and send to you. The rest should be easy. This is the difficult part for you to understand. With that, that's all for today. I'll see you all next week. Oh, forgot. Example 1. Example 1 kan? Tadi gua kan? Take a picture, write your name, metric number, take a picture, send in the group. Example 1. Yang pertama ni, yang first ni, yang tempat. Yang first sahaja. Yang second one tak perlu, yang first sahaja. Make sure you have your name and metric number, snap a picture, send in the WhatsApp group. Our test will be after semester break. I will inform. Okay? Don't worry. This one will be included. Next I will see which one I can include. Don't worry.